An automated step inside our AI research tool spent real money 10 times in a row. Not because anything decided to, because nobody had told the code to check whether it was allowed to. Not a bad decision, a missing question. We were running a research batch. 25 local businesses, read only, no contact, no spending authorized. That rule wasn't implied. It was written down explicitly before the batch started. No email verification spending unless separately approved. 10 of those businesses had real public email addresses on file. The moment those records hit our standard pipeline command, a function inside that pipeline automatically verified all 10 of those emails through a paid service. Automatically, as part of running the command, not as a choice made by anything. Confirmed, live, real API calls, not cached, not simulated. Nobody told it to run. Nobody approved it. It ran because the code had a valid API key sitting in its environment, and the code treated the key exists as the same thing as this call is allowed right now. Two completely different questions, answered as if they were one. This isn't a hypothetical failure mode we're warning you about. It's logged, dated, and fixed in our own systems, and we're showing you exactly what changed. The code that ran email verification didn't ask, "Am I allowed to spend money right now?" It asked, "Do I have an email and a key?" Two very different questions. The second one is always true. Once you've set up the integration, the key sits in the environment permanently, waiting. The first one should depend on what you're actually trying to do that specific day with that specific batch of data. Nothing in the code separated those two questions. If the key was present, the call went out. That's not a rare design mistake. It's the default shape of almost any integration, because add the API key is usually the entire setup step anyone remembers to do. Nobody sits down and writes, and now build a second system that decides every single time whether using that key is actually appropriate right now. That second system has to be deliberately added. It doesn't come for free. The first time this bug existed, it didn't spend anything. None of that batch's businesses happened to have a public email on file. The bug was still there. It just didn't get triggered. That's the dangerous kind of bug, the one that passes every test until the day it doesn't. A code review wouldn't have caught it either, necessarily. The code worked exactly as written. Nothing crashed. Nothing logged an error. The only reason it eventually surfaced at all is that a later batch happened to include real public emails, and someone was specifically checking spend records afterward instead of just checking whether the research output looked right. If that check hadn't happened, this would still be sitting there today, quietly capable of spending money on any future batch with real email addresses in it, and every batch after this one would have had a real chance of triggering it again. Every automation with an API key can do everything that key allows, all the time, unless something explicitly stops it. That's true whether it's an AI research tool, a marketing automation, or a script your team wrote 3 years ago that nobody's looked at since. The key doesn't know what today's task is. It doesn't know this is supposed to be a read-only research run instead of a live outreach campaign. It just knows it's allowed to make that category of call, full stop, forever, until someone revokes it or writes code that checks something beyond "Does this key exist?" That's true for email verification. It's just as true for a tool that can send a text message, post to social media on your behalf, charge a card, or update a customer record. The credential itself has no concept of context. Only code you deliberately write can supply that. We built 2 separate gates. One checks whether the credential exists, and a completely separate one checks whether the current run is actually authorized to spend anything right now. And if that second check fails, the system stops, not the developer catching it after the fact. That second gate is fail closed, which is the part that actually matters. If it can't positively confirm the current run is approved, the default behavior is don't spend, not spend unless told otherwise. Most systems, if they check permissions at all, default the other way. They proceed unless something explicitly blocks them. Flipping that default is a small code change with a large practical effect. On top of that gate, every external call now writes to an audit log too, Not just the ones that get blocked, all of them, so if it ever happens again, there's a record the same day, with the exact time, the exact call, and which run triggered it, instead of a surprise 3 weeks later that nobody can fully reconstruct. If any tool your business uses can spend money, send a message, or touch a customer's data, check whether it has the credentials to do that, and it's allowed to do that right now, are actually 2 separate checks in your system. For most tools we've looked at, they aren't. They're the same check, wearing 2 different names. You don't have to be able to read the code to ask the question. You just have to ask it. If I gave this tool a real live batch of customer data today that it wasn't supposed to touch, what would stop it? If the honest answer is nothing, it would just run. That's the gap this video is about. We found this in our own tooling before it caused real damage. 10 verification calls, not $10,000, not a customer's data. That's the version of this story you want to be telling, and it's only the version you get if someone actually goes looking before something bigger forces the question. If you want someone to actually check whether your automations have this gap, that's the audit we do. Links below.